Come back to the last question of WeBWork 6.2. It wants us to do the same thing. We have this function represented as a power series. We want the first few coefficients and then find the radius of convergence R. We'll go about it the same way. So there's a hair on my screen. Um, so previously, we used a very similar definition, knew that power series, and then just adjusted the power series with the coefficient, not the coefficients, but whatever was different, like this 2x or this 4. And the previous one had like a 5 and a 7. So we know arctan um, power series. We know that to be alternating and t to the 2n plus 1 over 2n plus 1. Which is just t minus t cubed over 3 plus t5 over 5 minus t7 over 7, and so on. That doesn't quite matter as much, but we can adjust that. Now we have 2x arctan of, I believe, 4x. So that will be 2x times the sum of alternating series. And now we have 4x to the power of 2n plus 1 over 2n plus 1, which is equivalent to series alternating. And then we have 2 times 4, 2n plus 1 over 2n plus 1 times our x 2n plus 2, which gives us, and when we do from 0 to 4, you can plug it in yourself. But once you plug in those values and you get those first few terms, we get x squared, 8x squared minus 128 over 3x the fourth. And you get more. You can get more, but there's no need because we need the first, I guess this is 4 to C4, but the first 5 terms. So when it's C0, we don't have a C0, which means it's 0. C1, we don't have a C1, so that means it's 0. C2, we finally have one. It's our 8. Here we go. C3, we don't have a C3, so it's 0. And C4 is negative 128 divided by 3. That is our first 5 coefficients. I think I kept saying 4 is 5. And now we need to find our R, which similar, the other one was 7x. This one's going to be 4x less than or equal to 1. So that can be written as 4 absolute value of x less than or equal to 1, which is just absolute value of x less than or equal to 1 over 4. And that is our radius of convergence, or 1 over 4, that is. And that is the solution to question 6.